Please open practical session 2 from Anastasia's website, and we will start. Guys, if you have any questions, please do not hesitate to ask. Please. I do not understand. You understand or not? Please ask. Okay, so what we have in our first problem. Originally, the labor market of production sector X was perfectly competitive. And, however, workers who did not feel happy about their wages established a labor union to maximize their total wage paid. So now we have union, and the aim of this labor union is the maximization of total wage paid. From the lecture, you know that we have three aims of labor union: maximization of total wage paid, maximization of rent, and maximization of number of workers. It was in the lecture. And in each task, you will have this information, what labor union maximizes. Okay, let the aggregate labor demand will be labor demand. And suppose the aggregate labor supply under perfect competition is given by find the difference between the unionized wage and the perfectly competitive wage. So we should find two wages if there is labor union in the market and if there is perfect competition in the market. And we should find this difference. Easy task. So I think we should start from perfect competition, because it's easier. We should cross demand and supply, and that's all. So if we have perfect competition, aggregate labor demand should be equal to aggregate labor supply. 180 minus V is equal to minus 30 plus 2V. From here, we find that equilibrium wage under perfect competition equals to how much? 70. Then, if we have labor union, from the task we know that we should maximize total wage paid. What is the total wage paid? It's wage multiplied by the number of workers, and that's all. Multiplied by the number of workers. But this union is the only seller of labor. It's like monopoly. Monopoly situation, the only one seller in the market. So, and what is wage multiplied by labor? It's like total revenue of monopoly. Yes? And if we have monopoly, we have the price of the good not constant, but the demand. Yes? Inverse demand function. It's like total revenue of simple monopoly. And this total wage paid, we should maximize by choosing the number of workers, non-negative. Let's find the inverse labor demand function. It's 108 minus L, and maximize this like total revenue of monopolies. First order condition equal to 0. From here we find that labor union wants 90 workers to be in the market, to work in the market. And what wage they want? They want maximal willingness to pay for their work. So we should put this number of workers into inverse demand. Yes, maximum willingness to pay. 90. That's all. So the difference between two wages is 20. This is the answer for our first task. But I want to show you on the graph how to solve this problem. What is the difference? So let's draw the sketch. Here, number of workers. Here, wage, the price of labor. And we have linear demand. 180, 180. Here, demand. Supply. If labor is equal to 0, wage is equal to 15. So from here, this positive slope. Our first task was to find perfectly competitive equilibrium. So we cross demand and supply here. Labor under perfect competition equal to 110 and wage 70. More interesting is to solve graphically the situation with labor union. What our labor union maximizes is she acts as monopolist, the only seller. Yes, she maximizes her total revenue. There is no costs. We do not have here costs, total costs. We maximize only total revenue. So what is the first order condition? The first derivative from total revenue is like marginal revenue. Yes. So this is like marginal revenue. And our first order condition, marginal revenue should be equal to 0. On our graph, what we know about marginal revenue for linear demand function? It is 2 times steeper than demand. Marginal revenue 2 times steeper. So here 90. And our first order condition, marginal revenue should be equal to 0, where labor is equal to 90. You see? So this is our labor if we have union. And then we found the number of workers for labor union, optimal for labor union. And then we put this number of workers into maximum willingness to pay for their work, into inverse demand function. So here, wage for labor union equal to 90. And this is the difference that we should find. Guys, is it clear? Please answer somebody.
Yes.
Yes, great. Okay, it was simple task. It's like the simplest task from, for example, from midterm or exam.
I will kill you. Horsey. Shit.
It's like the task where you should write down only the answer for the question, and that's all, without solution. This type of questions. So let's move on. Let's start our second problem. In our second problem, what we have? Imagine there is a bilateral monopoly. Bilateral monopoly. You know from the lecture what it is. It is the situation when we have both monopolist and monopsonist, only one buyer and only one seller in the market, both. Labor union, it's the only seller of the labor, one seller, labor union. And from the task we know, labor union which aims at maximizing its rent. That maximizes It's rent. And rent here, it's a kind of profit, not only total revenue, but full profit. Then, place against a single firm willing to buy labor. And we have only one buyer, only one firm. And when in the situation when we have only one buyer in the market, how to name it? No, one buyer in the market. Monopsony. One seller is monopoly, one buyer is monopsony. Right. And one seller is monopoly. And we have, if we have bilateral monopoly, we have two distributors at the same time. So then let our aggregate labor supply will be -4 plus 8u. We aggregate labor demand 30 minus 4u. Find an interval which the equilibrium wage must belong to. So we should find the borders, the interval for equilibrium wage. So what we have, let's do technical things like let's find inverse labor supply and inverse labor demand. It will help us in the future. So inverse labor supply will be L plus 4 divided by H, and inverse labor demand will be 30 minus L divided by 4. We'll use it. Then so let's discuss this situation. If we have one seller, we have monopoly. Yes, we want such wage that will be maximum willingness to pay for our work. Yes, so we will put labor, optimal number of workers into inverse demand function. Yes, and this will be the maximum wage. This word. Then, if we have one buyer in the market monopsony, and buyer wants to pay as less as possible, yes? So we will put optimal number of workers into inverse supply function. Why? Because this is the minimal price for which the good will be sold, yes? We know that inverse supply function is like marginal costs. Yes, what means marginal costs in the labor market? It means from which maximization problem we find this supply function of labor. We maximize our utility, yes, with our budget constraint. We choose how much we want to consume, how much we want to lie on the bed to have leisure time, and how much time we want to work. Yes, and this is our opportunity costs. We decide to work instead of leisure. So this is kind of marginal cost. This inverse supply function. So this will be the minimal price, the minimal wage for which we are ready to work, but not to lie on the bed. Okay, so let's start. We start with, for example, monopoly with our labor union. Our labor union maximizes its rent. Rent, it's kind of profit. Profit is total revenue minus total costs. Total revenue, we know from the previous task, it is inverse demand function. Yes, multiplied by L, it's kind of total revenue. Minus total costs. Once again, this is, for example, labor supply, and it's kind of marginal costs. How to count total costs? We should take the integral. Yes, it's the area under marginal cost. So here we write that this is the area from 0 to optimal number of workers, inverse supply function, the L. Here I write L wave because we have our variable in the orders. And this we should maximize by choosing how much workers we want to put into work. So this is kind of total costs, and this is rent, kind of profit. Because union is like monopoly, only one seller. Yeah, you see? So first order condition. First order condition, let's do it in these terms. First derivative. This will be the derivative from inverse labor demand function multiplied by L plus inverse demand function multiplied by the derivative of L, and it is 1. Minus. When we take the derivative from the integral, it will be the equation under the integral. Minus inverse labor supply. And this should be equal to 0. So our first order condition for a labor union that maximizes its rent is should be equal to inverse supply. This is kind of marginal costs, and this is kind of we found from the previous task. This is kind of margin revenue. Let's count. So, derivative from inverse demand minus 1 divided by 4 multiplied by L plus 30 minus L divided by 4 equals to inverse supply. L plus 4 divided by 8. And from here, we will find our labor. Let's do minus 12 divided by 4 plus. So here, 8 equals to 14 divided by 2. Mm-hmm. 56 divided by 5 equal to L. This is optimal number of workers. 56 divided by 5, it is 11.2. And then, what will be the wage optimal for union? We should put this number of workers, optimal number of workers, into maximum willingness to pay for the work, into inverse demand. So, the wage, optimal wage for union is how much? Inverse demand on L star. 30 minus 2 divided by 4. And this is, I will tell you, 4.7. So that's all for labor union. So now we found the maximal wage that can be in the market. Now we should find the minimum wage. Let's start. We should maximize something for only one buyer, for monopsony. What will be his maximization problem? Let's see. If I'm the only one buyer, let's mention I'm the only one buyer. I want to maximize my consumer surplus, yes, minus how much I paid for the good, yes. So what is the consumer surplus? This is the area under inverse demand, you remember, yes, minus how much I paid for the good. So we will maximize for one firm. Monopsony. The area under inverse demand minus how much I paid. How much I paid for the good? It's wage multiplied by number of workers. But if I'm the only one buyer, I control inverse supply. I control the supply of labor. So here, inverse supply of labor, as I'm the only one buyer. And this I should maximize by choosing number of workers greater or equal than 0. So this is the problem that monopsony solves. What will be the first order condition? Take the first derivative. This will be inverse demand minus ds prime multiplied by L minus inverse supply should be equal to 0. And let's rewrite. So the inverse demand should be equal to plus this is my how to say, this is my marginal revenue from product of labor or marginal value and this is, if this is total expenses, this is total expenses, this is marginal expenses. And if you compare this first order condition of monopsonist with first order condition of monopolist, they will be similar. Let's count. So here, 30 minus L divided by 4 should be equal to first derivative 1 divided by 8 multiplied by L plus 4 divided by 8. From here, we will find, I'll tell you the answer, optimal number of workers for monopsonist should be equal to 14. And then, if I'm the only one buyer, I want to pay as less as possible. I want to pay the minimal wage that our workers will agree for. So we put this optimal number of workers into inverse supply function. N plus 4, 14 plus 4 divided by 8, 18 divided by 8, and this is 2.25. So the answer will be, and in bilateral monopoly, we have both monopoly and monopsony, one seller and one buyer. And what will be the optimal wage, what will be equilibrium wage, depends on their bargaining power. We don't know. We know only the interval. So our optimal wage will belong to from 2.25 to the maximum wage. It was 4.7, yes? Mhm. We know only the interval. And then they will come and they will have debates and they will use their bargaining power, and we don't know what wage will be. For example, in the task, you will have the information that they have half of bargaining power belongs to firm, half of bargaining power belongs to union. So with such information, wage will be in the middle of this interval. But we don't know. Right now we don't have such information. Okay. Then let's do everything on the graph. Let's solve graphically. Demand linear function. Here inverse demand. Inverse supply. Supply was if L is equal to 0, wage is positive. So from here, for example, this is the supply. And we remember, if we speak about monopolist, it's a labor union that maximizes its rent. What is the first order condition? Marginal revenue should be equal to marginal costs. We know that inverse labor supply is kind of marginal costs, and marginal revenue for linear demand function 2 times steeper. Yes. This is marginal revenue. Cross it with marginal costs, and find number of workers optimal for the union that maximizes its rent. Then we want the maximal wage that we can have. We put this number of workers into maximum willingness to pay into inverse demand function. This will be our wage for union. 4.7. And where is the rent? The rent is under wage and above marginal cost. This is the rent as a kind of profit of monopoly. So then, if we speak about monopsony, let's look at our first order condition. In the first order condition for the monopsonist, we should cross inverse demand with marginal expenses. What are marginal expenses? We take the derivative from this inverse supply multiplied by L. But if you compare our first order condition for monopsony with first order condition for monopoly it was Vd prime multiplied by L plus Vd out of L equal to Vs out of L. You see, they are similar, yes, but we should revert everything for monopsonies. We should cross demand with marginal expenses, and marginal expenses, they are 2 times steeper than supply function. Okay. So let's draw 2 times steeper line. And, it should be accurate. Here was 11.2. We should cross in 14. So, for example, here. So this will be marginal expenses, 2 times steeper than supply. We cross it with inverse demand function. From here, we find the number of workers that monopsony wants to hire. For example, L of firm, LF, equals to 14. And then what our single buyer wants to do with wage. He wants to pay as minimal as possible. So he put this number of workers into minimal wage that can be in the market, into inverse supply. So this will be wage of the firm of monopsonist equal to 2.25. So this is the interval that we found. We have both monopoly and monopsony, so the optimal wage depends on the bargaining power. Okay, this is the equilibrium point for monopsonist, and this is the equilibrium point for our labor union or monopoly. Okay, this was the graphical solution. Please ask. Is it clear, guys?
Yes.
Great.
То, что нужно из одной точки на оси вот wage, где marginal expenses и supply.
Ну потому что там, смотри, оно в отрицательной области уже, да, пересекается. Мы должны в 2 раза круче.
Она пересекается в отрицательной области, да, не на самой оси.
Нет. А может на самой. Надо посчитать. Нет, она же вот в 2 раза круче идет. Она же, смотрите, еще раз, да, монопсония — это перевернутая монополия. Так голову переверните, у вас получается монополия. Правильно? Монополия откуда они уходят? Отсюда. Да, вот. Монопсония тоже вот отсюда мы должны идти. Вот, в 2 раза круче должно получиться. Но если не уверены, да, можете посчитать какой-нибудь там простой случай, просто взять и посчитать. Ну, типа, сейчас, давай там, типа, МС будут равны, ну, например, 2L. Может быть? Нет, может быть. 2L плюс 1. Так? Нам надо в 2 раза круче линии сделать. Это 2L плюс 1 умножить на L. Вот это взять производную. Это будет 4L плюс 1. Да? Нет, они, да, из одной точки, кстати. Да, видишь, получается, да, и да, в 2 раза круче, если L равно нулю, да, то все равно единица, да, здесь получается. Значит, да, значит, с одной точки. Спасибо.
То просто там важно.
Да. Согласна. Да, вот отсюда, значит. Супер. Хорошее замечание. Так, тогда стираем. Ну, давай, все. Let's continue. Our next task, third problem. Imagine an economy populated with a representative household and a representative firm. The household has preferences over consumption and leisure. So our representative household, his utility is square root out of 7 multiplied by leisure, where leisure belongs from, it is 1 minus how much he works, and belongs from 0 to 1. Then, her non-labor income is 2. Then, what about firm? Our representative firm uses only 1 input labor to produce the consumption good. And this is the technology, 2 square root out of L. Assume the price of the consumption good equals to 1. So the price of the final good, of the consumption good, equals to 1. And our task. First, as always, so find the aggregate labor supply, then the second will be aggregate labor demand, then labor, so on. So here, aggregate labor supply. Who supplies labor in the market? Household or the firm?
Household.
Household, yes. How our household decides how much labor to supply. He maximizes his utility with budget constraint. So let's maximize. Maximize our utility by choosing how much we want to consume non-negative and how much time we want to spend our leisure time from 0 to 1, subject to our budget constraint. Price multiplied by the consumption good, our expenses, should be less or equal than our income. Our income consists of two parts. Our labor income, it's wage multiplied by how much we work, and plus non-labor income. Our first step, we prove that we spend all our money. How we prove it? Let's suppose that in optimum we spend strictly less than we earn. Let's suppose that we spend now in optimum strictly less than we earn. So we have extra money in our wallet. Then, and we should prove that this is not optimal for us. How we prove it? For example, we can buy more consumption good, and our utility will increase. Yes, and we will buy this consumption good to the moment when we spend all our money. So, such that we will maximize our utility. Okay, so this was the proof. Then, what we will do next? Let's write our maximization program. For example, square root out of C multiplied by 1 minus L as labor, because we should find labor supply, not wage. Yes. Then let's write down our budget constraint. Let's put price on the final good 1. C is equal to wage multiplied by L plus 2. Non-labor income is equal to 2. And let's put this consumption good into our utility. Let's put it here and maximize by one variable. Which L plus 2 multiplied by 1 minus L. And this we should maximize by choosing how much time we want to work from 0 to 1. First order condition, we should take the derivative. Yes. Let's take our first order condition. It will be 1 divided by 2 square root out of all this multiplied by the derivative from the inside function. Here will be v minus 2vl, then minus 2. This should be equal to 0. So from here we see that our upper part v minus 2vl minus 2 should be equal to 0. From here now we will find labor supply. V minus 2 divided by 2v. And this is 1/2 minus 1 divided by wage. Then we should check that it belongs from 0 to 1. It should be greater or equal than 0. So now we should say something about our reservation wage. Our reservation wage will be equal to how much? When I begin to supply labor.
It's more than 2.
So, and we know that 1/2 minus 1 divided by v is always less than 1. It was in the previous class, the same function. So, labor supply, aggregate labor supply by aggregate, because we have only one representative household. So, will be 1/2 minus 1 divided by v, if wage greater or equal than 2 and 0, if wage belongs from 0 to 2. And also, I need inverse supply. We will find it. Inverse supply will be 2 divided by 1 minus 2L. Okay, this we will remember. Okay, great. This was labor supply. Now let's move on and find labor demand, aggregate labor demand. Second point, aggregate labor demand. We also know how to find who demands labor. Firm needs labor to produce the consumption good, so we should maximize the profit of our firm. In general, it is total revenue, price multiplied by how much she sells, minus total costs. Costs only for buying labor. Wage multiplied by labor. This will be 2 square root out of L minus VL. This we should maximize by choosing labor non-negative. First order condition. 1 divided by square root out of L minus V equal to 0. From here, labor will be equal to 1 divided by wage square. And this is non-negative for each wage, okay? So this will be labor demand. And inverse labor demand will be 1 divided by square root out of L. Why it is aggregate labor demand? Because we have only one representative for firm in our economy. As always, in each task, we should check second order condition and shut down if we have firm. We can check it here, for example, second order condition, minus 1 divided by 2L divided by 2 less than 0, okay. And shut down also okay, because we checked it in the previous class. The same, we had the same function. No, the same function we had in the previous class. But in your homeworks, you should check second order condition and shut down. So then, next. We should find the equilibrium if we have perfect competition. Perfect competitive equilibrium. In perfect competition, we should cross demand and supply. Demand aggregate should be equal to aggregate supply. And this will be 1 divided by V square equals to 1/2 minus 1 divided by V, only if wage greater or equal than 2. Yes, we cross on this part. Okay, let's multiply everything by 2V square. This will be 2 equals to V square minus 2V. b square minus 2b equals minus 2 equals to 0. D will be 4 plus 4 multiplied by 2. It's 12. So h will be 2 plus square root out of 12 divided by 2. And this is 1 plus square root out of 3. And we know that square root out of 3 is approximately 1.7. Approximately 1.7. So this will be approximately 2.73, and this is actually greater than 2. Okay. So we chose the right part. Great. So this is wage under perfect competition. And number of workers that will work under perfect competition. Let's put this wage into demand to supply. Never mind. 1 divided by 1 plus square root out of 3 square. And this will be approximately, I will tell you, 0.13. Next. After perfect competitive equilibrium, we should find equilibrium if who works. If a household becomes the monopolist in the labor market. If we have labor union that maximizes its rent, it's 0.4. Assume the household obtains an exclusive right to sell labor. In other words, so the economy ends up with a monopoly in the labor market. Only one seller, monopoly. Find the new equilibrium wage if the household maximizes its rent. It's like union maximizes its rent. Union that maximizes its rent. And rent is kind of profit for monopolist. So let's write down the maximization problem and then solve it. Maximization problem for our monopolist. Kind of total revenue, it's total wage paid, inverse demand for labor multiplied by labor, it's like total revenue, you remember from the previous test, minus total costs. Total costs, it's the area under marginal costs, and marginal costs are the inverse supply function. This we should maximize by choosing labor limit. From here, first do the condition. We remember VD prime out of L multiplied by L plus VD out of L, it's marginal revenue, should be equal to marginal costs, it's inverse supply. Okay, let's count. VD prime is minus 1 divided by 2 L3 divided by 2 multiplied by L plus 1 divided by square root of L equals to inverse supply 2 divided by 1 minus 2L. This will be 1 divided by 2 square root of L, 1 minus 2L. This I counted optimal number of workers. I counted to Wolfram. Optimal number of workers will be 5 divided by 2 minus square root out of 6, and it is approximately 0.05. More interesting is what about wage. If we have only one seller, he wants the maximal price, maximal willingness to pay. So we will put this optimal number of workers into inverse demand. This for union or for household, another task here for household. Put this number of workers into inverse demand, into maximum willingness to pay. This will be inverse demand 1 divided by square root out of 0.05. And this is approximately 4.47. So now we found the wage that will be set if we have only one seller of labor.
В предыдущем пункте, в третьем, можно было рассчитать рейд?
Можно? Fifth. In the fifth point, we have firm, only one firm, and she acts as monopsonist. Yes? One buyer, monopsonist. And we should write down the maximization program. What our monopsonist will maximize. We remember from the previous task what only one buyer maximizes. It maximizes, she maximizes her consumer surplus minus expenses. Yes? So the consumer surplus is the area under inverse demand function minus total expenses. Total expenses, it is minimal price multiplied by labor. It's total expenses. Total expenses, and this is kind of total value, consumer surplus, something like that. And this we should maximize by choosing number of workers. Let's put everything we know, but we will not solve it because it's not obligatory here in our task. Do not provide any derivations. It's written in the task. But let's put everything. From 0 to L, inverse demand was 1 divided by square root out of L wave. The L wave minus inverse supply, I forgot. 2 divided by 1 minus 2L multiplied by L. And this we should maximize by choosing labor and net. And from here, we can find optimal number of workers and then put optimal number, optimal wage will be minimal wage that the workers will agree for. So optimal wage for the firm, we should put this optimal number of workers into inverse supply. And our first order condition, you remember, yes, in general, its inverse demand function should be equal to marginal expenses, to the derivative from this Vs prime out of L multiplied by L plus Vs out of L. This is marginal expenses. And this is marginal value or marginal revenue of product of labor. Great. So let's do everything on the graph. Graphical solution. As in the previous task. But here we have demand. Graph is 1 divided by V square is a hyperbola. This is the demand. Supply also reversed our hyperbola, and we know that reservation wage is equal to 2. So we have 0. Supply of labor 0 from 0 to 2, and then like this. Yes. Perfect competition, demand equal to supply. Here, labor for perfect competition. Here, wage. If perfect competition, then if we have monopoly, one seller, that is labor union. It was 0.4. In 0.4, first to the condition, marginal revenue is equal to marginal costs. Supply with marginal costs, marginal revenue is steeper than demand. We cross marginal revenue and marginal cost. From here, we find how many workers, or how much time our household wants to work if he's the only seller of the labor. And then we put this into maximum willingness to pay for the work. And this is wage for our household, or wage for union that maximizes its rent. Then this are for union, for our household. 0.5, one buyer, monopsonist. His first order condition, we should cross the demand with marginal expenses. And marginal expenses, not 2 times, but steeper than supply function, inverse supply. For example, here, this marginal expenses. Demand equal to marginal expenses. From here we find how much workers our single firm wants to hire, wants to buy as monopsonist, as the only buyer. And then we put this number of workers into a minimal wage that our workers will agree for, into inverse supply function. This will be wage for our firm, because buyer wants to pay as less as possible. So here we have 3 equilibriums. This monopoly equilibrium, it was 0.4. Then monopsony equilibrium 0.5, and perfect competition, it was in 0.3. Guys, please ask questions. Is it clear? I don't have different color today, but I think it's okay. So for this problem set, that's all. I stop our recording.
Explain what means do not provide any deviations in